In a world where humanity is preparing to leave Earth behind, two small spacecraft carry the weight of a colossal question. What really happened to Mars? Billions of years ago, the red planet might have looked like a sister to our own world: blue skies, flowing rivers, even oceans. But now, it stands as a frozen tomb, its air stripped away, its surface scarred by time and radiation. NASA's new ESCAPADE mission is designed to uncover the truth, to retrace Mars' atmospheric death, and to learn how we might prevent the same fate here on Earth. This is not just another mission. This is a scientific time machine, and its name is ESCAPADE. The forgotten past of a living world long before Earth's continents even settled into their current forms. Mars may have been thriving. Satellite scans have revealed dried-up riverbeds, deltas, and minerals that only form in the presence of water. But today, the planet's air pressure is less than 1% of Earth's, and its once protective magnetic field is long gone. Scientists believe that a planetary catastrophe unfolded when Mars' molten core cooled. Without that spinning metal heart, the magnetic field collapsed, leaving the atmosphere unguarded. The solar wind then began to erode Mars layer by layer, blowing its air and water into the endless night of space. For decades, NASA has tried to piece together this cosmic crime scene. Now, the ESCAPADE twins, Blue and Gold, are about to gather the final clues. ESCAPADE, two identical eyes watching Mars missions named ESCAPE and Plasma Acceleration and Dynamics Explorers, perfectly captures its essence. Two identical satellites, Blue and Gold, built at the University of California, Berkeley, will orbit Mars together like synchronized dancers. Each is small, only 120 kilograms, but carries some of the most advanced plasma instruments ever made. By comparing data between the two crafts, scientists will get the first ever 3D, time-varying view of how the solar wind interacts with the Martian atmosphere. It's like taking a planet's pulse, but from 200 million kilometers away. The revolution of small but smart in the past, exploring a planet meant billion-dollar budgets, decade-long timelines, and massive spacecraft the size of buses. But ESCAPADE breaks that model completely. At just $80 million, it's part of NASA's Small Innovative Missions for Planetary Exploration Simplex program. Proof that big science no longer requires big money. By using modular electronics, 3D printed parts, and commercial off-the-shelf systems, engineers at Berkeley have built a world-class mission at a fraction of the cost. As principal investigator Rob Lillis said, "We're entering a new era where small spacecraft can do truly big science." Inside, the twin Explorer spacecraft is equipped with 3 specialized instruments: ESA electrostatic analyzer, tracks energetic ions and electrons that shape Mars' invisible plasma halo; EMAG miniature magnetometer, measures faint magnetic ripples, remnants of the planet's ancient field; ELP Langmuir probe, samples plasma density and temperature, allowing scientists to see how solar storms strip the atmosphere molecule by molecule. These sensors will operate in perfect coordination, streaming data back to Earth every few seconds through NASA's Deep Space Network. Imagine 2 tiny robots orbiting a planet millions of kilometers away, listening to the silent song of its dying air. The journey that redefines interplanetary travel, ESCAPADE's path to Mars, is unlike any in NASA's history. Instead of a direct trajectory, the satellites will spiral outward to a solar parking orbit near a Lagrange point, where Earth's and the Sun's gravity balance. There, they will perform calibration tests for nearly a year before slingshotting around Earth and heading toward Mars in mid-2026. This slow, energy-efficient route may reshape how future missions reach other planets, making interplanetary travel more flexible and affordable. NASA engineers describe it as a cosmic dance with gravity, a choreography only possible through modern orbital mechanics. Launching on the wings of Blue Origin, the liftoff will mark a historic first. For the first time, a deep space NASA mission will launch aboard Blue Origin's New Glenn rocket, a massive 2-stage booster capable of lifting over 45 metric tons to orbit. Scheduled for November 9, 2025, the launch will take place at Cape Canaveral Space Force Station in Florida. If successful, it will cement Blue Origin's place alongside SpaceX as a key player in planetary exploration. The collaboration represents a new alliance. NASA's scientific expertise meets private innovation, bridging government precision with commercial speed. The science behind the mission: when the ESCAPADE twins reach Mars, they'll enter elliptical orbits that skim the upper atmosphere at different altitudes. By comparing plasma flows and magnetic field data, scientists will reconstruct how energy from the sun interacts with the planet, a process that literally sculpts Mars' skies. These measurements could explain why some parts of Mars still retain trace magnetic fields, while others are completely barren. It may even help us understand whether life could ever return or if it ever existed in the first place. The mission's core objective: to decode the invisible forces that determine whether a planet can breathe. Why it matters to us on Earth: ESCAPADE is not just a Mars mission, it's a mirror. Earth too is constantly bombarded by solar wind. Our magnetic field deflects most of it, but understanding Mars' demise offers a glimpse of our potential future if that shield ever weakens. As climate change, solar activity, and space weather become more unpredictable, this mission could guide how we protect our technology, satellites, power grids, even astronauts from the sun's fury. It's a scientific investigation with existential implications. Voices from the team inside NASA's Goddard and Berkeley labs. Engineers describe ESCAPADE as the most human small mission ever. Many of the scientists are graduate students, some working on a spacecraft for the very first time. Dr. Shannon Curry, a plasma physicist on the team, said, "It's emotional. We're not just studying Mars, we're building the tools that might one day protect our own planet. Every wire, every screw carries not just data, but hope that human curiosity will always outpace cosmic decay." Beyond science, the cultural symbol ESCAPADE also represents a symbolic milestone. In an age of mega projects and AI-driven exploration, it reminds us that ingenuity still comes from people, not just machines. 2 satellites, one blue, one gold, mirroring the colors of Berkeley's emblem, represent unity between academia and exploration, between curiosity and courage. What happens after Mars? Once the mission completes its 2-year science phase, the satellites may continue in extended operations, possibly serving as relays for future Mars landers or rovers. But more importantly, the technologies proven here: miniaturized plasma instruments, dual orbital coordination, autonomous navigation will inspire a new generation of twin probe missions to other worlds. NASA is already exploring Venus ESCAPADE and Europa mini orbiters concepts using similar designs. Looking ahead, the age of agile exploration: success of ESCAPADE could redefine how space science works: smaller budgets, faster development, and more missions per decade. It's the same philosophy that powered the private space revolution now being applied to planetary science. Imagine dozens of ESCAPADE-like pairs orbiting planets across the solar system, each telling a different story about atmospheric loss, magnetism, and habitability. That's the vision NASA is quietly building toward. A message for the future: when the first signals from ESCAPADE reach Earth, they'll travel for nearly 20 minutes across the void, the same delay that once separated human voices between Apollo astronauts and mission control. Somewhere in that faint signal, there's a message written not in words, but in data, a whisper from Mars saying, "I was once alive." If humanity is listening carefully, perhaps this time, we'll learn before it's too late. Closing narration: the red planet awaits as the countdown begins at Cape Canaveral. Floodlights bathe the New Glenn rocket in a golden glow. Inside its fairing, 2 small spacecraft wait silently, their journey programmed, their destiny uncertain. At T-0, the engines ignite, and the roar of thunder drowns out the Florida night. Blue and gold rise together, tiny emissaries of human curiosity chasing a ghost planet millions of miles away. Their mission is simple: to tell us what happened, to show us what could happen again, and to remind us that in the end, every question we ask about Mars is really a question about ourselves. Because to understand how Mars died is to understand how Earth must live.